Hello everyone. So my name is Harsh Nagrani and today we'll be continuing our binary search series, and today we'll be looking at the lower bound technique. What is lower bound? And we'll code it as well. First we'll get an understanding of what this lower bound is all about. So lower bound is something where you have to return the index where the element at that particular index is either greater than or equal to the target. Okay, so let's take an example here. We have an array and we have elements 3, 5, 8, 15, and 19, and our target is 9. Okay, so our answer is 3. How 3? Because array at 0th element, array at first element, and array at second element is less than target. So as we all can see, 3, 5, and 8 are less than target, and the first element, that is either greater than or equal to the target, is 15, which is at index 3. So we'll return index 3. So again we'll be using the binary search approach for this. um, but before the binary search, let's just look at the brute force approach. So what is the brute force approach? The brute force approach would be like something like what I just did, traversing the entire array from the first element. So we'll just see the first element, compare it, and then if the condition is satisfied, then just simply return the answer, or else just move ahead. But again, the time complexity is O of big O of n. Um, we have to see if there is something better than this. So yeah, binary search is there, and we'll be using binary search to solve this problem. How? Let's just understand that with the help of an example. So here we can see example where we have 1 2 3 4 5 6 7 8 elements, and our target is 3. So we have to return the index where the nums index is either greater than or equal to the target. So as you all can see, the target is 3. 3 is present here at an index 2. So your answer should be 2. Okay. But before jumping directly to the answer, let's just look at the approach. So it will be like a classic binary search algorithm, but the difference between the previous code and this code is that here we'll combine the mid condition and the start condition, and the target greater than condition and the mid condition. Okay, so first here we'll find the mid. Mid is 3. So we'll check, since nums at mid 3 is greater than equal to target, our condition is satisfied. So now we'll store the answer is equal to mid, and we'll bring our end to mid minus 1. Why? Because since mid is one of our answers, mid can be one of our answers, so there is no point in checking answer which are ahead of mid. Okay, because mid is already the least number, least answer, the smallest answer, and the numbers after mid are greater, so there is no point in searching after mid. So we'll bring end to mid minus 1, and then we'll continue our loop. So now our end is at second position, as we can see. Again we'll find the mid is at 1, but now the nums 1 or the nums mid is 2, which is not satisfying the condition of array of mid greater than equal to the target. Array of mid greater than equal to the target. So since it is less, so now we'll bring our start to mid plus 1. So now we have our start and mid both at the same position. So now we'll check again, the condition is satisfied, nums mid is greater than equal to the target. We'll store the answer, and then we'll reduce our end, and then we stop. uh, so I guess the approach is clear. So now we'll directly jump to the coding part, and let's just look at the code. So this is the code, and here we have defined the array, which is 1 2 3 4 5 6 7 and 8, and we have our start, we have our end, we have our target, and then we have our answer, which is currently 0. And we are running a while loop, and we are exactly doing what we just discussed. If our condition is correct, or is it satisfied, then we'll store the answer, we'll update the end, or else we'll simply increment or redefine the start. Okay, so if we just run this, our answer is 2. and our correct answer is 2. We can do one more thing. uh, what we can do is, answer, instead of answer is equal to mid, we can also write answer is equal to minimum of answer comma um, mid. But to do that we have to do this int max. So I guess this should also work. Yes, this is also working. But usually it's okay if you don't do that, because anyways the mid will be the smallest element, smaller than the end. Okay, mid will always be smaller than end. So it's okay if you don't do that, if you just keep it 0 and just bring it to answer is equal to mid, it's also fine. uh, if we change our array to, let's say, if we remove this 2 and directly keep 3, and if we remove 4 and directly keep 5, and now if our target is 4, so what it should return? It should return 2, because 3 is less than 4 and 5 is greater than equal to 4. So the lower bound will be 2 again. It is returning 2. So yeah, this is the lower bound solution. And in the next video we'll be looking at the upper bound, how we can do the upper bound and what will be the approach there. It is, and that is also very very much similar to the lower bound. So yeah, that was pretty much about lower bound. Hope you understood the concept, and see you in the next video. Thank you so much.